Good morning. Good morning. How many of you are there? Where is Vedant? Good morning, Prasad. Chala, join fast. Good morning, Kanak. Okay. Good morning, Mrunmai. Only 8 students send me the PDF. Okay, now we will continue our third chapter, that is transducer. We will try to complete that chapter today only. Do you? Wait for 2 minutes, 2-3 minutes. Okay, transducers. This one is a chapter of paper 1. This one is a short chapter, near about 3 to 5 marks. Now this year it may be maybe 2 questions, 7 to 8 marks. This chapter is for now 7 to 8 marks. Now in our last lecture we discussed about active transducers and passive transducers, also the classification of transducers. Okay, transducers means the device which converts non-electrical quantity into electrical quantity. It is termed as a transducer. It is like sensor. It works as a sensor, means it sends non-electrical quantity and convert that quantity into electrical quantity. There are different type of transducers, but they are basically categorized as active transducers and passive transducers. Active and passive transducers. Now what is the difference between active and passive transducer? This is one of the important question on transducer. Define transducers and give classification of or differentiate between active and passive transducers. Active transducers means they are also termed as a self-generating transducers. Active transducers means they are self-powered transducer. They does not require external power for their operating. That's why they are termed as active transducers. Okay. Passive transducers means the transducers which required external power for their operation. Means for which operation they try to convert that non-electrical quantity into electrical quantity. So they must work, and for their working they are externally powered. That's why they are termed as a passive transducers. Okay. Active transducer, for example, thermocouple are the active transducers. Thermocouple means in a thermocouple temperature is converted into, means thermal energy is converted into electrical energy. What is thermocouple? That we going to thermocouple, just in short I am going to tell you. Do you know thermocouple? I think you learned in physics. Seebeck effect. Do you studied Seebeck effect in physics? Antimony and bismuth pair of thermo. Good morning, Kalpesh. Do you know thermocouple? Tell me yes or no. ओके ओके, बाकी आहे. ठीक आहे. त्यावेळी तुम्हाला जास्त चांगलं समजेल. आधी तर एखादा एकच क्वेश्चन यायचा त्याच्यावर 3 to 4 मार्क्स और मॅक्सिमम 5 मार्क्स. बट आता सगळंच बदललंय की नाही. काही चॅप्टर बराचसा पोर्शन ओमिट झालाय, तर प्रत्येक चॅप्टरचं वेटेज वाढणार. 7-8 मार्क्सला पकडून चला. तुमची एक्झाम होण्याच्या आधी मार्किंग स्कीम पण येईल. बाकी ते काही डिटेल आलेलं नाहीये अजून. पण आहे ते क्वेश्चन तर असणारच आहे, पण त्याचं वेटेज वाढेल. आधी एकच क्वेश्चन येत होता या चॅप्टरचा, तर 2 येऊ शकता. ओके, किंवा 2 येत होते तर 3 येऊ शकता. आणि आज चॅप्टर संपेल सुद्धा. आतापर्यंत मी तुम्हाला कुठलं शिकवलंय? फक्त थर्मिस्टर. इन आवर लास्ट लेक्चर वी डिस्कस अबाउट थर्मिस्टर. प्रायमरी याचं बेसिक सगळं आपण शिकलोय. व्हॉट आर ट्रान्सड्युसर्स. प्रत्येक ट्रान्सड्युसर आपण ऑलरेडी कुठे ना कुठे कनेक्टेड आहे, म्हणजे कुठे ना कुठे आपण शिकलोय, कुठल्या तरी सिलेबस मध्ये गेलेला आहे, आयदर इन फिजिक्स और इलेक्ट्रॉनिक्स. ओके. Where is Vedant? Vedant is absent today, na? So, we are discussing about active and passive transducers. Active transducer, for example, thermocouple. प्रसाद राईट. बघूया आता लवकरच क्लासरूम मध्ये भेटणार आहे, मग बघते मी एकेकाकडे. Thermocouple, that Seebeck effect, that the two dissimilar, whenever what is Seebeck effect, whenever two dissimilar metals are joined together to form antimony and bismuth. Whenever two dissimilar metals are joined together to form a pair of metals or to form a two junctions, then that is known as a thermocouple. Two dissimilar metal. Which metals we considered here? Antimony and bismuth. Here two junctions are formed. Whenever one junction is heated and another is kept cool in ice, and here one junction is heated, means whenever temperature difference is maintained between these two junctions, that EMF is generated. Suppose between that two across that thermocouple we apply or we connect galvanometer, then there is a deflection in galvanometer. Deflection means galvanometer is a current detecting instrument. So there is some current in a galvanometer, means it shows that thermal energy is converted into electrical energy. So non-electrical quantity is converted into electrical quantity with So here antimony and bismuth, two wires are taken and two ends are connected. So two junctions are formed. In our laboratory we are going to perform one important experiment on thermocouple and it is very simple. See in your practical book. सगळ्यांनी practical book घेऊन ठेवायला. Read that thermocouples experiment. So here what happens whenever one junction is heated and another is kept cool, at that time due to the temperature difference automatically AMF is generated. That property is in certain metals only. That metal series is given in your physics book. Whenever that thermoelectric series, that metals, if we consider that upper metal and downward metal, then the maximum EMF is generated. That is better thermocouple is of antimony and bismuth. Maximum EMF is generated. So that thermal energy externally, which energy we provide, means which we convert, that thermal energy is converted into electrical energy and no external power supply is required. That's why it is a self-generating transducer or active transducer. Okay. So about the thermocouple and active and another all other maximum thermocouples are passive transducers. Passive means for their operation to convert that non-electrical quantity into electrical quantity, there is a necessity of external power. That's why they are termed as a passive transducer. For example, LVDT, thermistor, LDR, capacitive transducers, all other are the passive transducers. So if we try, if the question is like that, define transducers and differentiate between active. ओव्हरलुक केलंय मी मृण्मयी एकदा फास्ट रिव्ह्यू आणि मी इंडिव्हिज्युअल एवढ्या 2 दिवसामध्ये तुम्हाला इंडिव्हिज्युअल त्याचे करेक्शन देते. गोइंग टू रीड आणि मग एका पेपरवर मी ते करेक्शन लिहून त्याचे फोटोकॉपी तुम्हाला सेंड करते इंडिव्हिज्युअल. प्रत्येकाचे कारण मिस्टेक्स वेगळे असणार ना. ओके, बघितलंय मी म्हणाले ना आता इथे थोड्या दिवसांसाठी आली ती, तर त्याच्या मागे माझ्या गडबड असते सध्या. पण तरी पण मी 1-2 दिवसात तुमचं रात्री एकदा कंप्लीट करते आणि सेंड करते इंडिव्हिज्युअल तुम्हाला. आता हे लक्षात आहे ना, उद्याचं लेक्चर आपलं 2:00 ला असेल आणि फ्रायडेचं सुद्धा 2:00 ला असेल. फ्रायडेचं बघूया. हो हो देणार मी चेक करून, कारण मग तुम्हाला एक्झाम द्यायला मजा नाही राहणार ना, मी जर तुम्हाला लवकर चेक नाही करून दिले तर. कारण मला मल्टिप्लेक्सरची पण एक्झाम घ्यायची आहे. नेक्स्ट वीक मध्ये आपण मल्टिप्लेक्सरची मक्स डिमक्सची एक्झाम घेऊ. ओके. आता बघाल आज आता सगळ्यांनी टेक्स्ट बुक घेऊन बसा, म्हणजे मला कमी पेपर वर्क करावं लागेल. सॉरी, बोर्ड वर्क मला कमी करावं लागेल आणि खूप सोपं आहे. तुम्ही एकदा रीड केलं तरी संपेल. एक 2-3 पेजेसच्या याच्या फक्त नोट्स आहेत, त्याही मी लगेचच सेंड करते. हा ऍटलिस्ट हे बघा, प्रसाद मला रिमाइंड करशील आजच्या आज तू याच्यावर व्हॉट्सअपला पर्सनलला मेसेज करत राहा जर मी तुम्हाला ट्रान्सड्यूसरच्या नोट्स सेंड नाही केल्या तर. एकच आय थिंक एकच पेज आहे माझ्याकडे. त्या पेजमध्ये असं कॉलम वाईज प्रत्येक ट्रान्सड्यूसर, त्याचं वर्किंग, त्याचे ॲडव्हान्टेजेस, डिसॲडव्हान्टेजेस, जसं की मी तुम्हाला फ्लिपफ्लॉपचा दिला की नाही, फ्लिपफ्लॉपचा दिला तशा नोट्स आहेत ह्या चॅप्टरच्या माझ्याकडे. 1 पेज नोट्स दॅट आर सफिशियंट फॉर यू. बाकी चॅप्टर एकदा रीड कराल फक्त, पण मग त्या नोट्समधनं सगळे ट्रान्सड्यूसर येईल. फक्त 1 लास्ट 2 पॉइंट्स आर ओमिटेड. काय ओमिट केलंय नीट लक्षात ठेवा सगळ्यांनी आणि बुकमध्ये स्किप करा. लाऊडस्पीकर जो एक ट्रान्सड्यूसर आहे दॅट कन्वर्ट्स दॅट साऊंड एनर्जी इंटू इलेक्ट्रिकल एनर्जी, तो पॉइंट कट केलाय. आणि गॅस सेन्सॉर that is also omitted from the syllabus of this chapter. All other remaining 3-4 transducers are discussed and there is a question on that only. Okay, so after that in our last lecture we studied about thermistor temperature dependent resistance. It is having high sensitivity. It is constructed of the material having negative temperature coefficient of resistance. For that just we discuss about negative temperature coefficient of resistance, NTC. NTC means whenever temperature increases its resistance decreases and conductivity increases. Means NTC material means what? Whenever the thermistor's temperature increases its resistance decreases. Means that temperature is a non-electrical quantity and resistance is electrical quantity, but to measure the resistance we have to connect external power supply, then only we understand whether there is an increase or decrease in resistance. That's why this is the thermistor is passive transducer. Thermistor is a passive transducer and it is generally means there are some PTC transducers also, that materials are different. Here maximum times that thermistor is made up of NTC material, negative temperature coefficient of resistance. And which materials are generally used? That is oxides or cobalt, copper, carbon, nickel. Oxides of these metals are used as an NTC material to construct that thermistor. And external construction, there are 3 types. It may be bead type. Bead means one round, जसं तुमचं माचीसची काडी असते ना, like that. That is termed as a bead type. 2 ends are taken out, that are the 2 terminals of that thermistor. Or disc type, 1 disc, and inside that material, that oxide material or that thermistor material is between that disc and 2 ends are taken out. Another one is the means bead type, rod type, and third one is what? Rod type. One rod is there and across that, at the center of that rod, that NTC material is deposited and 2 terminals are taken out. Okay, that is the thermistor. And see that graph in our last lecture, we just discussed that graph, that along x-axis we plot different temperature. We start from -100, 0, then 100, 200, 300. The sensitivity of this thermistor, it works properly from -100 to 300 degrees Celsius. Means variation in temperature is properly monitored from -100 to 300 degrees Celsius, and the change in resistance is maximum. This is the high sensitive resistance. Means for a 1 degree Celsius change, there may variation in the resistance by 6 ohm. म्हणजे एका डिग्रीने टेम्परेचर चेंज झालं तरी पण रेझिस्टन्स मध्ये होणारा चेंज हा खूप मोठा असतो. दॅट्स वाय वी मे से दॅट दिस इज द सेन्सिटिव्ह ट्रान्सड्यूसर. Okay, and see the advantages and disadvantages, that graph and diagram of that thermistor. After that, the important transducer, second transducer we are going to discuss, that is the piezoelectric transducer. Second transducer is a, see page number 55, piezoelectric transducer. Piezoelectric transducer. So, what is piezoelectric effect? याच्या आधी केव्हा तरी एकदा डिस्कस केलाय आपण हा इफेक्ट. Piezoelectric effect means whenever that piezoelectric crystal is subjected to pressure or tension. You understand the difference between pressure and tension? Pressure means in this direction force is applied, and tension means in this direction force is applied. So whenever piezoelectric crystal is subjected to pressure or tension, that electric charges are developed across that crystal, and that effect is known as a piezoelectric effect. Okay, and this is also I think active transducer. This is also active transducer. Means when piezoelectric crystal, there are two examples of piezoelectric crystals are two, that is quartz crystal or Rochelle crystal. These are two examples of piezoelectric crystal. Whenever this crystal is subjected to pressure, then electric charges are developed across it. Now what is the direction of that? On one side, suppose positive charges are developed, and on another side negative charges are developed whenever pressure is applied. When we keep that crystal under tension, means in opposite direction force is applied, then the charges are also opposite. Initially here positive charges, now due to the tension on this side, means the direction of current changes whenever we apply pressure and when we apply tension. The direction of current changes. So that is known as a piezoelectric transducer. So how that piezoelectric transducer is constructed, see in your textbook, or in short I am going to draw that diagram. Suppose there is a solid base like this, and here your that crystal, piezoelectric crystal. Now through force summing membrane, pressure is applied through pressure port. means what is the electric current developed that is taken across that crystal. So here we write the output and here we write that crystal piezoelectric crystal. So here four summing membrane, that is like your diaphragm. Directly the crystal will direct pressure नहीं apply करना. Through the four summing membrane we apply the pressure to this pressure port, or we apply the tension also. In any direction we are going to apply the pressure on this crystal, and whenever pressure is applied, means what is the input quantity? Pressure, that is the non-electrical quantity, or you may say that displacement, that non-electrical quantity, and we get out at the output there is a electric current. EMF is generated across that crystal. And whenever pressure is subjected to tension, then the charges are in opposite direction. The direction of EMF also reversed. Do you understand? This piezoelectric crystal or piezoelectric transducer. What do you say in short about piezoelectric transducer? It converts that input pressure or displacement into a electric quantity. Therefore, pressure is converted into electrical energy. Okay, and for that you have to state first piezoelectric effect, that whenever piezoelectric crystal is subjected to pressure or tension, that EMF is generated across the crystal. Okay, that is the property of that crystal. Not every material is not giving you piezoelectric effect. Only two type of crystals, that is quartz crystal or Rochelle crystal, subject to pressure, then EMF is generated across them. Do you understand? Go through it once. On page number 55, read that each and every point. I am going to wait 2 minutes. See that diagram and read that paragraph. If you do not understand anything, then please ask. Do you understand? All of you read that paragraph. Now here we can complete two types of transducer. Thermistors, that is the passive transducer, and this one is active transducer, that is the piezoelectric transducer. Now third one we are going to study, that is LVDT. Any question? Do you have any question? LVDT, that is the linear variable differential transducer or transformer, sorry, transformer. Now for that we are going to draw the different diagram than this textbook. Simple diagram is given in your notes also, and that is also the better diagram. याने तुम्ही confuse व्हाल textbook मधल्या diagram ने. So draw what I am going to draw. Draw this diagram. Here there is a transformer. Here primary winding across which primary AC voltage is applied, and what is the output of secondary? There are two secondaries, but they are in series opposition. सरळ सरळ नाही काढलेल्या. Two secondaries are there. We studied in 11 that are transducer, different type of transformers. Wait. Here the primary winding and two secondaries of the transformer. That two secondaries are equal number of turns, but they are connected in series opposition. बघा ही अशी ठेवण्याच्या ऐवजी असं केलंय, म्हणजे याचं स्टार्टिंगचं एंड आणि याचं हे एंड याच्यामध्ये आउटपुट घेतलंय. सो दे आर इन सिरीज opposition. Means according to that there is a change in direction of EMF. So output E0 equal to E1 minus E2. So input applied primary voltage is here, and this one is the primary voltage. So what happens here? Your core, whenever there is alignment of that core on this side, on the side of as we displace that core on the right hand side, E2 is more than E1. E2 is more than E1, therefore E0 is equal to minus sign. Means more EMF, E2 is more, and whenever that core is displaced on this side, at that time magnetic flux linkage between E1 and primary are more. That's why E1 is greater than E2. So output E0 is positive. Do you understand? Means by the movement of external applied force, whenever the core position changes, the flux linkage with primary and secondary changes. Due to that, output EMF changes. Means that non-electrical quantity is converted into electrical quantity. For the operation of that, we have to apply that primary voltage. That's why that one is a passive transducer. This is also termed as a displacement transducer. Means input quantity, that displacement or pressure is converted into the external EMF. Okay. So here that by applying external pressure, that displacement of the core on either right hand side or left hand side, and that according to that the EMF is developed, or EMF at the output we measure, and that is proportional to the displacement of that core. Do you understand? Are you listening? All of you. So that graph you have to plot. Here on y-axis we are going to plot EMF, and here core position. What? Core position, output voltage. Means whenever that rod is on this side, right hand side. Okay. When that core on right hand side, at that time more flux linkage with E2, E1 is less than E2. That's why we get EMF on the like this. EMF on coil phase 2 goes on increasing, that we graphically present. And here whenever we move that core on this side, left hand side, then there is a flux linkage between primary and secondary. Okay, E1 is more than E2. That's why we show the direction on negative y-axis. Here your left hand side and here your right hand side. Do you understand this? So better way you draw this diagram for LVDT transducer, primary and secondary winding of the transformer. That's why it is termed as the linear variable differential transformer. Maximum time the question on LVDT. You have to draw this diagram, write down the output equation, draw this graph, discuss about this graph and about this. So draw this diagram and write down the equation. Do you have any question? Any question? Draw the diagram. Okay. Okay, Prasad and Kalpesh. When you finish, please tell me. Okay. Now there means if the question on that explain that linear variable differential transducer, then you have to draw this diagram, explain that diagram, draw this graph, you have to explain that graph and also discuss the advantages and disadvantages of that LVDT. What are the advantages? It is there is a linearity, a linear relation between that input and output. It is a highly sensitive transducer. That is the second advantage. Third one, you may say that low power consumption is there. It does not require much more power for its operation. That is also one of the advantage. Okay. And what is the disadvantage? Okay. And what is the disadvantage? That magnetic flux linkage surrounding may affect that magnetic flux linkage, so shielding is necessary. Okay. And environment temperature, due to the temperature change we may get wrong result, so we have to keep that assembly in a constant temperature. These are the disadvantage of that LVDT. Go through it, read. परत एकदा हाई ट्रान्सड्यूसर एकदा 5 मिनिट्स देते, रीड कराल एकदा. On page number 57. And what happens, important point I forgot to remember, whenever that core is exactly center, then we say that E1 is equal to E2. At that time we get output E0 is equal to 0. EMF is 0. That is the null point. Whenever E1 EMF in coil across the secondary winding 1 and EMF across secondary winding 2, both are same, though so E1 minus E2 equal to 0. So we get output equal to 0. Okay. After that, the next one. Light transducers. Example of on page number 58. Light transducer. Just I discuss in short because you know all about this LDR, light dependent resistance. 11th ला पण शिकलोय ना आपण LDR, light dependent resistance. Okay, input light energy, due to the variation in intensity of light, the resistance of that material changes. For example, which material is that photosensitive? Photosensitive material is used in LDR like CDS, germanium, silicon, CDS, cadmium sulfide. That material is sensitive to light, means in dark its resistance is infinity. Whenever no light falls on that LDR, डार्क मध्ये म्हणजे अपूर्ण अंधारामध्ये त्याचा रेझिस्टन्स काय असतो, इन्फिनिटी असतो. आणि जसं जसं त्याच्यावर वेगवेगळ्या इंटेन्सिटीचा लाईट पडत जातो, इंटेन्सिटी वाढत जाते, तसं त्याची रेझिस्टन्स काय होतो त्या मटेरियलचा कमी होतो. पण मग रेझिस्टन्स मोजण्यासाठी आपल्याला एक्सटर्नल पॉवर अप्लाय करावी लागेल, तरच आपल्याला करंट वाढला की आपण काय म्हणणार, रेझिस्टन्स कमी झाला. आणि करंट कमी झाला की आपण काय म्हणणार, रेझिस्टन्स वाढला. ओके. सो दॅट इज अबाउट द लाईट डिपेंडंट रेझिस्टन्स. गो थ्रू इट. सोपं आहे बघा, वाचा. आपण कितीतरी वेळेस LDR, LED, that is nothing but like LED, it's operating. Okay, so LDR is one of the passive transducer because it required externally powered transducer. Okay, material used you have to remember, that is cadmium sulfide, germanium, silicon. And what is the working principle? Input light energy is converted into electrical energy. Light energy is the non-electrical quantity. It is converted into electrical energy through that LDR. Another example is optocoupler. We also discuss optocoupler. On one side there is a so before that LDR, you have to see the symbol of that LDR also. There is a ते 3D अप्पर व्ह्यू दिलाय म्हणून तुम्ही ही काढली तरी चालणार आहे, त्याने तुम्ही कन्फ्युज व्हाल म्हणूनच तर मी ही डायग्राम दिली. ओके, ओके प्रसाद, ही काढली तरी चालेल, याच्याने जास्ती क्लिअर होतं. हे तुम्हाला कळतं ना की फ्लक्स लिंकेज बिटवीन प्रायमरी आणि सेकंडरी वाढलं की सेकंडरीच्या अक्रॉसचं पोटेन्शियल वाढणार आहे, आणि फ्लक्स लिंकेज बिटवीन प्रायमरी आणि सेकंडरी कमी झालं की आउटपुट कमी होणार आहे. हे तुम्हाला माहिती आहे ट्रान्सफॉर्मर बद्दल. सो whenever there is a movement of that core, there is a change in output EMF. Okay, so after that LDR, LDR सहज समजेल. LDR चा सिम्बॉल बघा कसा लक्षात ठेवाल. LDR ना incoming light you have to show, that is the symbol of LDR. After that optocoupler is discussed there. Optocoupler means on one side there is a photoelectric diode, photodiode, which emits the photons, which emits the light, means electrical energy is converted into light energy. And another side there is a LDR, which sends that light and gives the electrical energy at the output. And conveyor belt is there, object counting. Whenever on that conveyor belt object is there, that light is interrupted and no light fall on that LED. Due to that, LED cuts off that process of converting that input light energy into electrical energy, that is the instantaneous. That's why as soon as that LDR turns off, with that one counter system counts 1. Like that, again that means that both photoelectric diode and that LED, photodiode and LED, that assembly is known as optocoupler. 2-3 वेळेस डिस्कस केलंय आपण हे ऑप्टोकपलर. ओके, सो आफ्टर दॅट optocoupler, displacement transducer, last one transducer is remaining, that is the capacitive transducers. आणि मी नोट्स देते आज, त्या एकदा रीड कराल. कॅपॅसिटिव्ह ट्रान्सड्यूसर वी आर गोइंग टू डिस्कस डिटेल. त्याचं पण प्रिन्सिपल तुम्हाला माहितीच आहे. कॅपॅसिटन्सच्या प्लेट मधलं डिस्टन्स कमी झालं की C is equal to epsilon 0 AK upon D. At the denominator means distance between two metal plates is inversely proportional to capacitance. डिस्टन्स कमी झालं की कॅपॅसिटन्स वाढणार, डिस्टन्स वाढलं की कॅपॅसिटन्स कमी होणार. आणि कॅपॅसिटन्स मेजर करणं हे इलेक्ट्रिकल क्वांटिटी आहे, आणि डिस्टन्स आणि कॅपॅसिटन्सचं रिलेशन याच्यामध्ये व्हेरीफाय होतं. सो दॅट वन इज द कॅपॅसिटिव्ह ट्रान्सड्यूसर. दॅट वन इज अ सिंगल ट्रान्सड्यूसर रिमेनिंग. I have to finish because at 9 o'clock Khushi's last paper is there today. उद्याच्या लेक्चरला आपण कॅपॅसिटिव्ह ट्रान्सड्यूसर फिनिश करू. उद्या आहे ना आपलं लेक्चर 2 o'clock ला, 2 PM. ठीक आहे, ओके, बाय.